Hi guys, welcome to another video of Physics 2. In this case, we're going to see the motion in one dimension. Okay, so when I say one dimension, what I mean is the object or a person or something is going to move, but only it's going to do it in one dimension. That means uh, from left to right or up and down. Okay, that's one dimension, but not both, because if we have both dimensions, well, yes, it will be two dimensions, but in this case, it will be only one dimension. Another thing that is important to say is that we are going to have a reference system. Reference system. Okay, the reference system is something that is going to help us in order to determine where is going to be the positive direction and where is going to be the negative direction. So for example, if I got the motion from left to right, okay, so let's say that I'm going to have something as my reference system that is going to be, okay, from this point, this black dot over here, everything that goes to the right is going to be positive, and everything that goes to the left is going to be negative. Now, the reference point, most of the time, is something that is not going to be moving. Okay, um, all the things in the universe, they move. Okay, but there is something called the relative motion. Okay, for example, if we are seated, okay, we are not moving respect from the floor, but of course the earth is moving, is rotating. So I hope I made myself clear when I'm talking about a reference system. Is something that we are going to use in order to say, okay, from this point, everything that goes to the right is positive, and everything that goes to the left is going to be negative. Okay, so we're going to have two equations that we are going to use in order to solve the problems on this topic. So I'm going to write them both. This is the first equation. In a moment, I'm going to give you the definition of each letter, and this is the second equation. Okay. Plus, let's move it a little bit more. Plus, okay. These are the two equations that we are going to use. Okay. A stands for acceleration, and BF is final velocity. BI is for initial velocity. XF is for final position. XI is initial position. And the time, T is time. Now remember that we are going to work with vectors. So it will be the acceleration vector, the final velocity vector, the initial velocity vector, the final position vector. But from this point, most of the books, they don't draw the little arrow above the letters in order to identify them as a vector. So I'm not gonna do it, but let me tell you that we are going to be working with vectors. So that means that everything, all these letters are vectors except the time. I mean, remember that the time is not a vector. And another important thing, these are the only two equations that I'm going to use. It doesn't matter the type of the problem. I mean, talking about one dimension, I'm going to use these equations. Of course, there are more equations and you can look for them over the internet. But sometimes it's a little bit I don't recommend you to have many equations because you need to memorize them, and each equation is going to do something different, and depending on the problem, you're going to use an equation. So in each problem, doesn't matter the problem, I'm going to write these two equations. I'm going to use them always. But when I substitute the values or something like that, well, I'm going to cancel letters and then I'm going to get a new equation. So I hope I made myself clear that I'm going to use only these two equations. So let's do the first problem, that is here. Now, I'm not gonna do the problem on this screen because I don't like working with PowerPoint. So I'm gonna do all the operations right here, but I'm gonna read it over here. It says a person drives her car at a constant velocity. Okay, constant velocity is a very important term that I'm going to explain in a moment, of 51 kilometers per hour when passes the main street. It says initial position equals 0. From there, she continues in a straight line for 4 minutes. What is her position respect from the main street in that time? Okay, so in this problem, what I'm going to do is to write the data. So it says constant velocity. This term means that the velocity is not going to change. So that means that it's going to remain exactly the same. And also this is a motion that is called like this, uniform linear motion. Okay, if you got constant velocity, we got uniform linear motion, or known as ULM. Okay, so when we got constant velocity, that means that the initial velocity equals the final velocity. So in this case, the velocity is 51 kilometers per hour. I repeat, if the problem says constant velocity, that means that the velocity is not going to change. So that means the velocity, initial velocity, equals the final velocity. And another important thing, if the velocity is constant, that means the acceleration equals 0 meters per second square. Because I don't know if you know the definition of acceleration. The acceleration is the change in velocity. I repeat, the acceleration is the change of velocity. So in this case, there will be no change in the velocity. The velocity is going to remain exactly the same. So that's why the acceleration is 0 meters per second square. Okay, so let's continue. When passes the main street, initial position equals 0. So the main street is our reference system, is something that is not going to move. And from that point, we are going to begin to say, okay, from this point, the direction is going to be positive or negative. And most of the times, guys, the initial position is 0 meters, is 0, always. 99% of the problems that we are going to see here, the initial position is 0. Okay, now in this problem, for example, I told you about the reference system, that everything that goes to the right is positive. If the problem does not mention that direction, well, I recommend you that you assume the direction is always positive. So you assume that the motion goes to the right, so we can work with positive values. Okay, and then it says that from there she continues in a straight line for 4 minutes. So that's the value of time. Time equals 4 minutes. Okay, and what is her position respect from the main street in that time? So that means after 4 minutes, what would be her position? So for example, if I want to make the drawing, so here, I'm sorry for my bad drawings. So this is initial position, so the car is going to be moving, and after 4 minutes, okay, it's going to stop. or I don't know, it's going to continue, but we are going to measure the distance here. So this is the time from this point to that point. Okay, those are 4 minutes. So what will be the final position when 4 minutes ends? So this will be the final position, and that's the constant, that's the letter that we are going to find. Okay, after I got this, I recommend you to write the equations. Always acceleration equals final velocity minus initial velocity over time. Always. It doesn't matter that you already memorized them. It is very important for you to write them. Final position equals initial position plus initial velocity multiplying time plus the acceleration times square over 2. Okay, and then from this point, I'm going to cancel everything that is 0. So if you see, I got the acceleration equals 0 meters per second square. So the acceleration is 0. So if acceleration equals 0, so that means the whole equation is 0. So I'm going to cancel the whole equation because it's 0. And then what else is 0? Initial position. So I'm going to cancel initial position and also this term over here that includes the acceleration. Okay, so if you see, the only equation that I got left is final position equals initial velocity that multiplies time. So you can look for this equation. This is the equation when we have uniform linear motion. But if you see, we got this equation from these two original equations. So it's up to you if you want to memorize, look for the equation for uniform linear motion and memorize it, or you can work with the two original equations and from there, well, you can cancel and you can substitute and you can do a lot of things and you can get the final equation that we are going to use. Okay, so from this point, I'm going to use the initial velocity, that is this one, and the minutes. But if you see, these are minutes and these are hours. So we need to transform. We need to transform the time so I can have the same units in time. So I recommend to transform these kilometers per hour into meters per second and these minutes into seconds. So let's do it. First, I'm going to transform 51 kilometers per hour. I'm going to transform them into meters per second and I'm going to use the conversion factor. So using the conversion factor, it says that, okay, kilometers, I want meters. So I need to eliminate kilometers. So kilometers is above. So I'm going to write it here below. And what I want meters. Okay, I'll write them in the opposite side. I mean up instead of down. And I'm going to say 1 kilometer is 1,000 meters. And from here, I need to cancel hours. So if I want to cancel hours, okay, I'm going to write them in the opposite side. So this is hours. I'm gonna write here hours, and what I want are seconds. So what I'm gonna do is 1 hour is 3,600 seconds. So I'm gonna use this I'm gonna do this operation in the calculator. So I'm gonna do this fraction, and it's going to be 51 times 1,000 over 3,600. Okay, and I press equal, and that's the value of the initial velocity. Now if you see, that's an infinite value, so what I'm going to do, I'm going to save this infinite value in a memory of the calculator. So I'm gonna press shift and I'm going to look for the STO key, and then I'm going to select any letter that I want. In this case, I'm going to select the letter A. So if I do it correctly, the answer got save or storage in the A memory. Okay, alpha A, so I can see that I saved it properly. Okay, so I'm gonna write here that this is 14.16, only 2 decimals, 16 meters per second. Okay, and also the time is 4 minutes. 4 minutes. Okay, the only thing that I'm going to do, I'm going to multiply them by 60 seconds because 1 minute got 60 seconds. So how much is that? 4 times 60 seconds, 240 seconds. Okay, so let's do this. Let's perform that operation. Initial velocity is 14.16 meters per second. That is going to be multiplying 240 seconds. Okay, so if you see seconds, it's going to be eliminated with seconds and it will remain meters. So let's do in a calculator. It will be 240 times the value of the initial velocity that I got saved in the A memory. So alpha A, and I press equal, and that is the answer. The final position, final position equals 3400, and what are the units? Meters. And that's the answer of this problem. Now remember that we are working with vectors. This is a vector. Remember that the number is the magnitude and the sign is the direction. So that means that the car went in this direction. Positive means right. If the value was negative, well, that direction will be going to the left, but this is not the case. Okay, this was the first problem about motion in one dimension, guys. If you see, this problem was using constant velocity, and that means that is the uniform linear motion. Stay tuned because we're going to see more videos about this topic. See you guys.